Welcome back to my channel. As you all know, myself, Smruthii, studying in Sri Venkateswara College of Engineering. Today's subject is mathematics. Topic vectors. So now let's go on to the topic. Vector algebra. Introduction to vector algebra. Vector algebra deals with mathematical operation on vectors in multidimensional space. Vectors have magnitude and direction, and they are represented by arrows in the space. The basic operations in the vector algebra include addition, subtraction, scalar multiplication, and dot product. Vector algebra. In the case of addition, it connects head to tail. In the case of subtraction, flip the arrow end and then connect to the head to tail. Vector addition and subtraction. Vector addition involves adding the corresponding components of two vectors to find the resultant vector. Vector subtraction is similar to addition but involves the subtracting the components of one vector from the another components. The resultant vector of addition or subtraction can be found using the parallelogram law or triangle law. Scalar multiplication of the vectors. Scalar multiplication involves multiplying a vector by a scalar quantity. Multiplying a vector by a positive scalar changes the magnitude of the vector without affecting its direction. Multiplying a vector by a negative scalar results in the vector with the same magnitude but opposite direction. Dot product of the vectors. The dot product of the two vectors is a scalar quantity. It is obtained by multiplying the magnitudes of the vectors and, and cosine of the angles between them. The dot product is commutative, destructive, and follows rule A dot B is equal to mod A mod B cos theta. The dot product can be used to find the angle between two vectors or to calculate work done by a force. Cross product of the vector. The cross product of two vectors results in the vectors that are perpendicular to both input vector. The magnitude of the cross product is equal to the product of the magnitude of the input vectors multiplied by the sine of the angle between them. The direction of the cross product vector is determined by the right-handed rule. Applications of vector algebra in mathematics. Vector algebra is widely used in mathematics to describe the quantities such as force, velocity, and acceleration. The laws of motion and electromagnetism are often formulated using the vector algebra. Projectile motion, circular motion, and torque are the examples of the physical phenomena that can be analyzed by using the vector algebra. Vector spaces and linear dependence. Vector space is a set of vectors that satisfy the certain properties including closure and the addition and subtraction. Vectors are said to be linearly independent if no vectors in the set can be written as the linear combination of the others. Linear independence is most important in applications such as solving the systems of linear equations. Linear vector space. The vector spaces of the quantum mechanics are like the ordinary three-dimensional spaces of the vectors from introductory physics. Vectors in a three-dimensional space. Any vector can be expressed as d is equal to d1 e power d1 x1 square plus a2 x2 square plus a3 x3 square. Vector projections and components. The vector projection of vector onto another vector is a scalar quantity that represents the component of the first vector in the direction of the second. The component of a vector in a given direction is the projection of the vector onto a unit vector in that direction. Finding vector projections and components is useful in solving the problems involving in the forces, velocities, and distances. Now coming to the last part of this topic, that is conclusion of the vectors. Vector algebra is a powerful mathematical tool for analysis and solving the problems involving the quantities with the magnitude and the direction. Understanding vector operations such as addition, subtraction, scalar multiplication, dot product, and the cross product is essential in the various fields including the physics, engineering, and computer graphics. Mastering vector algebra can enhance the problem solving skills and provide the insights into the geometric and physical properties of the vectors. I hope this gives you some information which is useful. Drop a like for it. Thank you.